Hello and welcome back to another Craig and Dave Unscripted. Regular viewers or users of us will know that we've had a programming offer available for a long time called Time, and Dave has been working diligently over the last year. Started off as a little bit of a pet project, a few tweaks here, a few user suggestions. It's a complete typical Dave overhaul from start to finish. So it was originally called Time version 2, but we've now rebranded it Time to Code. And I won't tell you too much about it. It actually launched a little while ago, but this is the first video sort of wider to the community. We've renamed it Time to Code. It's completely free now. So Dave, introduce it to everyone officially. What is our new programming offer, Time to Code?
Yeah, thanks, Craig. Well, at the moment, we've only got Python. So originally, Time version 1 also included a C# version. We don't have that available at the moment, but I'm hoping during this academic year to work on the C# version. So maybe this time next year, hopefully we might have a C# version 2. No promises there, but we'll see how things pan out. So at the moment, yeah, we've got Time to Code, which is Time version 2 that I was talking about last year, an evolution of Time version 1. And as you say, it's now completely free. Used to be part of our membership premium resources. And we've decided actually moving forward, we're going to make all our programming materials completely free for everyone. So yeah, starting with Python, then C#, then we'll get into other things, maybe Pygame, maybe Defold, other bits and pieces, but we'll talk about that in the future. So yeah, let's have a quick look, shall we, at the old version of Time to understand maybe what some of the differences are here. So those of you that have used Time version 1, you may be familiar with these PowerPoint style workbooks, which is a sort of classic Craig and Dave approach. All of our classroom resources are presented as PowerPoint presentations because it's just easier to display them on the whiteboard, and students can add text and images and objects to a single slide without all the pagination issues you get with applications like Word, for example. So that's what we've traditionally done, and that's what Time version 1 was presented as. And so what we used to do is give the students a sample program that they had to type in and show them, because it was Python, where they needed to indent their code, which was always a little bit tricky, to be perfectly honest, but there we go. So the students would type out the code. That would take them a little bit of time, and we kind of convinced ourselves, didn't we, that it was good practice, because when we were young, we used to type out code from magazines into the computer, fix our little syntax errors, give the code a run, and you know, we thought, well, it was good enough for us, it's good enough for them, right? I think the reality is that that was the only way of doing it in the old days, wasn't it, Craig? You had no choice but to type from a magazine because there was no other way of distributing code, right?
Yeah.
So so we just kind of went with it, and there is some, you know, useful practice in there, but it is time consuming and it does take the students time, and it is frustrating if they get the indentation wrong or they misspell a keyword or something like that. You know, they get syntax errors before they even get going. So having identified that as being an issue, we wanted to eliminate that. That was one thing. Then the way that we described the programs was to have these little call outs, and it was all very text based. The students had to read what it is that they were learning in these programs, and that didn't really suit all learners. So we're quite keen to change that as well. Then we had a little sample program and another chance to have a look at some syntax and explaining what the program was doing. Another sample program, some more explanations of what the program was doing. So a lot of these slides were literally the students just reading what they had to do. Then we had a sort of summary slide of what they've learned, presumably what they've learned from reading all those slides. But the reality is the students were just typing out the code, giving the program a run, getting on to the next one, typing out the code, giving it a run, getting on to the next one. And they were just getting through these workbooks really as quickly as they could.
Without really taking it in.
Yeah, exactly. Without really taking it in. So it felt like this slide was really good, and it was trying to introduce them to programming terminology, which is really important. But they just weren't taking it in. It's too much to read. They just overlooked it. So keen to solve that problem as well. Then we had these little questions that are all part of the PRIM approach. This is the investigate stage, where you look at a piece of code, there are questions to answer about it, and you know, that helps your program comprehension. This was good. This was a good feature. We wanted to keep this, but there wasn't a huge amount of structure to it in terms of which programs have which questions, and so that was something to think about. Okay, then there was some keywords and a little glossary of keywords. Again, this was great. This was really, really useful. We needed to keep that. And then we had some Parsons problems in some of the programs, but not all of the programs, for students to, you know, change the order of the code statements, but they still had to type the code into the computer to give it a run to see if it would work. So that was, again, something to consider. There were very few Parsons problems, actually. They were very sporadic. And there was no real structure as to why we were presenting something as a Parsons problem or not. And the slides, because they're quite, they're not very tall, you couldn't fit many statements on a slide. So that was a little bit of a problem as well. I couldn't do Parsons problems for big programs. So we needed to overcome that as well. And then we had our classic make programs. So make a program that does this, make a program that does that, and they all have points. So like, you know, 1 point, 2 point, 3 point, which was our differentiation. If I just scroll through these, we can see these are the 2 point problems, and then we had the 3 point problems as well here. Now that was great. It was great for differentiation. However, for the weaker students, so the ones that need a little bit more support, well, there just wasn't more support. That's really part of the problem. So could we address that? Could we somehow take these problems and break them down into a series of success criteria? Because that would be good practice for A-level when they have to do a project of their own and they have to identify success criteria. Well, where do they learn what that looks like? What do we mean by success criteria? So I thought maybe that was an opportunity to make a change. And I like the icons, though. That added a little bit of color to the page. So I was quite keen on that, and maintaining the differentiation. Some of the programs were a bit too hard. I appreciate that. They were a little bit too hard, and some people said some of them are a bit too mathematical. So we've looked at the balance of all that and tried to improve it. So that's the old version 1 of Time. It was good. It served a purpose.
Yeah, it's probably just worth mentioning there. I mean, if people are hearing the word time for the first time, which a lot of you might acronym, you've seen the little graphic in the bottom right-hand corner that's been changing. So the idea here, and we haven't changed this, the idea here is that a good way to learn to program is to try something, then investigate it, and then make your own version, then evaluate. And this is an evolution of a more common term that a lot of people are aware of in teaching computer science, PRIM. This is not a new concept. So the underlying pedagogy of trying, investigating, making, and evaluating, which is our take on PRIM, that's still very much embedded. Hence why the new version is called Time to Code. So it wasn't changing the whole pedagogy of how people should learn to program. It was more, as Dave's going to show you, all those little problems we identified. Text heavy, this, not enough room on the page, they have to type everything. It was more of just, so we're not changing the time philosophy. Well, I'm not going to say anything more. I'm going to let you reveal it, but I thought it was important to bring in.
Yeah, absolutely. Okay, let's have a look then. So welcome to Time to Code, which is Time version 2, but that didn't sound particularly appealing. So I thought, well, what can I do with that? Time to Code, brilliant. And then we came up with the domain name timetocode.today, which I really, really liked. So yeah, gone are the workbooks. And I know some of you out there are saying, where are the workbooks? We want the workbooks. Well, the workbooks are gone, I'm afraid. We just don't think they really were workbooks. At the end of the day, they were just a sequence of slides that told the students what they had to do. And we thought we could make better use of a website to do that. So they weren't really workbooks. You're not missing anything. Here is the new Time to Code website. And we're getting loads of questions about assessment and how I should use the scheme and things like that. And we do actually have a button that says teachers start here. And if you go onto that page, you will see that I've written loads and loads of pages on this scheme and how it works. Now, I'm not going to go through all these today, but obviously, how do I get started? The first link is getting started. You know, have a read of all that. Couple of other things to note. As Craig said, that the pedagogy and the lesson components are still all there, stronger than ever, I would argue, stronger than ever. This is a real upgrade from Time version 1. As Craig said, it started out as a bit of a nip and a tuck. You know, we were getting some feedback and Craig said, oh, Dave, you know, do you think you could change this a little bit and add a bit of that? And I thought, yeah, I could do that. And it just ran away from me, if I'm honest, because the more I evaluated it, the more I realized what I could do with it. And it just got bigger and bigger and bigger. And in the end, it took me a whole year to actually recreate it. But I genuinely think it was worth it. This is the best scheme that we've ever written in terms of programming. And it is the culmination of 25 years of our teaching experience about the best way to learn to code.
And that's one thing, sorry, that's one thing we kind of promised to our Craig and Dave users, whether you're a paid user or not, that we're continually evaluating what we do and improving and tweaking it. And we're on that journey with you. It was a running joke in the company for a while. When's Time version 2 going to be finished, Dave? But, you know, it would have been very easy to just go, oh, I'll make that change. I'll throw a few more graphics in. I'll reduce the complexity of the text and make it look a bit, make it a bit easier to read. We could have done that. But we didn't, you know, it was pouring in what was already good, taking something new. And yes, it's taken a bit longer, but this is where we're at. So, you know, that's part of, I hope, what you appreciate from what we do at Craig and Dave. Sometimes it doesn't get there really quickly, but when it gets there, hopefully it's the best it can be. And then we'll still iterate and improve on this. We've got loads of ideas, but as we said, we can discuss those in future videos. Yeah, absolutely. And in case you never spot it, I just want to highlight up here the little button that says, I can do this. I mean, how many times as a teacher have you come across students that say, it's too hard, I can't do it? And it's really frustrating because programming is so central to the understanding of computer science that I just think that to be a good computer scientist, you need to be a good programmer. They go hand in hand. So we've put a little page together here about having a growth mindset. I'm not going to go through it, but that button is on every single page of the website. So when your students say, I can't do it, then go over to their computer, click the little button that will always be in the top right-hand corner and say, you can do it, you just can't do it yet. Yeah. And that's a completely different way of thinking about it. So I know there are teachers out there that are going to love this. And that's an example of some of the little nips and tucks that we've done to just make this the best it can be. So let's get into it then. So what we've got is basically 9 levels. I'm not going to go through them all in this video. We're going to have a look at them sequentially in future videos. But we've got 9 levels, and we have changed that up a little bit from Time version 1. We've made some conscious decisions about where students get stuck and how we can alleviate those issues. So a couple of notable examples. Firstly, yes, it's functions first. Okay, and I know that that's controversial, and some teachers out there are going to say, you teach functions and procedures far too early. You should be doing it later in the scheme. And I just say, why? Because it's one of those things that students really struggle with. If they struggle with it, then don't get them programming loads and loads and loads of programs and then introduce it later, and they have to completely change the mindset that they've got in terms of how they write programs. It doesn't make sense. If it's difficult, teach it early. That would be my advice. I think that's one of the biggest issues in teaching actually at the moment. It's like, things are difficult, we'll do it later. No, because they're difficult, do it earlier. I really am quite a fundamental believer in that, and it pays dividends. And our students, they struggle at first. Our students are no different to anybody else's students. Of course they struggle. But once they get over that barrier, the rest of their coding journey is just easier. Things slot into place. So, sorry, it is functions first. I make no apologies for that. But notice something else. Condition-controlled iterations in level 3
and count controlled iterations in level 6. So we've split them out because we thought to ourselves, well, our students struggle to understand what the real difference is. Why would you use one rather than the other? And so we've deliberately split them quite far apart in the levels so that each type of iteration has a specific purpose.
And you can understand and embed the purpose of why that iteration is important. And of course, I'm sure you're going to get there, but if you just scroll down a bit, those eagle-eyed people will have noticed that just before level 6, we introduced one-dimensional arrays and lists. Well, that's not a random coincidence, is it? Because obviously, as we know, a count control loop, a typical for loop, is great at iterating through an array or a list or a data set. And of course, at that point, it's like, I can see the benefit. I understand the difference. So yeah, again, a lot of the stuff is in a very similar order to before, but we've just taken, or you've taken the opportunity to really carefully think about concepts, the order introduce, how to add less confusion, less sort of cognitive overload. So yeah, it's really good, really good.
Definitely. And each of the 3 levels, as I've said, once you get to the end of level 3, 6, and 9, those are the places where students lose their understanding. They start to struggle at those points. So we've done it quite deliberately. So level 1, inputs, outputs, and structure. So you might not like functions first, but as Craig said to me, Dave, you can't just pass parameters in the very first program. They've been learning in Key Stage 3 how to do inputs. You can't just ignore that. And to be fair, I did ignore that because I thought inputs should be part of validation. We'll do that much later. And that was probably a mistake. They've been learning inputs in Key Stage 3. Why wouldn't we continue that? But the rigor at Key Stage 4 is to now put that into a sub-program instead of just sort of taking inputs, as it were. So that's what we've done. So inputs are back in level 1. But so what we've got is inputs, outputs, and structure programming. Selections, that's ifs and matches, and then level 3 condition controlled iterations. So that's a while loop. So at that point, that essentially is some good Key Stage 3 knowledge there. So, plus a little bit of rigor with the structured programming. So that's the point at which you can write quite a lot of useful programs just with those commands. And if you haven't mastered those commands, inputs, outputs, if statements, and while loops, you need to not go any further until you've mastered those concepts. Otherwise, you're just building more and more and more on rocky foundations, or sandy foundations, or whatever the foundations are, not very secure. You know what I mean. And then the other thing that you'll notice in blue is we've got these new assessment points, and it makes sense to have them after level 3, level 6, and level 9. And we'll look at those in detail in future episodes. So we'll quickly dive into one of the levels. We're not going to look at it in detail, but we'll just have a quick look at the structure so you can see how that has changed. So let's just pick level 2. This is selections. So it tells the students what it is that they're going to learn. And then it's got 3 programs to learn new techniques. And this structure is embedded in each of the levels. So level 1 is the same as this. Level 3 is the same as this. All the levels are the same. So you've got 3 programs to learn some new skills. Then you've got 6 practice programs to practice those skills. And again, we've got the star rating. So 1-star programs, 2-star programs, 3-star programs, for example. And again, we'll look at those in more detail another time. But if we have a quick look at, say, one of these one of these learning programs, then you'll see this is where time comes out. So we've got try, and this time we've given the students the code as a trinket, but we have a Replit version of this as well. And this is the critical difference. We now have videos that explain the code. So I type out the code, and as I'm typing it out, I'm explaining what I'm doing and why I'm doing it. And that is infinitely better than the callouts we were using in the old workbooks. And it's based on a new pedagogy. I say new, it's 2018, but new to me anyway, this idea of live coding. So you write a program on the board and the students are watching and following, and you're explaining what you're doing. I think most of us have done that years and years and years ago. And how frustrating is it when the students are following at a different pace, and and say my program doesn't work, and oh, it's a nightmare getting a class of 30 students to follow what you're doing on the board. So we've now got videos that they can watch individually, and this is just a new way of teaching. It's just so much better to give the students video and let them have a look at it individually. Then we've got our investigate questions, and this has got a bit more structure now. So the first learning program has the two easier questions. The second program has 2 harder questions, and the third program has 2 hard questions. Again, we'll look at that in more detail another time. Then you've got making the program. So what we do here is we say, well, the program that we gave you at the start for you to try, so you don't have to type it out anymore, the program that we give you to try, you can then extend that program, so add to its functionality. So again, we've got a link off to the little Trinket window. That's where the code is, and again, version in Replit. And we've got success criteria now. So it tells them, it breaks the problem down and tells them exactly what it is they have to achieve, with some typical inputs and outputs from the program. And here's our old sort of knowledge organizer section that is a handy reference to the keywords that you've learned in this particular program. And then crucially, for every program, we now have a set of flowcharts, and we have a Parsons problem for every single one.
Now, I'm just going to interrupt there. For every single program, I was very impressed. There was a period where Dave was doing nothing but producing flowchart after flowchart. There are hundreds of these, but it does mean you've got that differentiated support now. Some students will go straight in. Some students will go, oh, I'm a little bit. Well, have a look at a flowchart. Have a look at the logic of it. Oh, I think I can try it now. And, you know, maybe a student's struggling even more. Well, look, let's give you the lines of code and you try rearrange them. And then next time, you know, try another problem, but this time try it without the Parsons problem. Try it now. Now you've got the idea, just try the flowcharts. So every program has multiple levels of support and differentiation. It was a very big undertaking. I think you were starting to see flowcharts in your sleep at one point.
Yeah, it's just an example of how it just ran away from me. You know, I had a good idea of how we could differentiate the success criteria by, you know, if students are struggling to write code, then we can give them some boilerplate code, which is what we do, which is another difference to Time version 1. They don't start from a blank sheet. Even the hard programs have some comments in them that the students can then write code underneath. But yeah, having this idea of, oh, I can't do it, sir, and then being able to give them a flowchart and say, well, here are the logical steps. Can you turn that into the code? And then some of them will inevitably be able to succeed at that, and some will struggle and say, no, I can't, I need more support. Okay, well, now give them the Parsons problem and the flowchart, and they can rearrange the code statements in the Parsons problem by following the flowchart without actually writing any code at all. And then once they've got the program in the logical order, then they can type it up and give it a run and see how it works. So there's multiple layers of differentiation in this scheme that didn't exist before. And then we've got a little evaluate section, which we'll look at another time. So that's the kind of broad structure, if you like, of what these learning programs look like. And it's very similar for the practice problems as well. If we just quickly go into one of those, there's no video this time because they use the learning programs to learn what they're doing. Now we've just got some make challenges, but again, we've got these success criteria. And instead of just saying to the students, you've got to structure it using subprograms, we know this is hard. We're telling them now what code to put in each subprogram. And we've got little code stubs in the code so that they can, those that struggle with the whole idea of subprograms, they've got that scaffolding. They're not starting from a blank screen, and they can follow this, and it makes more sense. And as we've just said, you've also got flowcharts and Parsons problems with every program to help them. So this is a massive upgrade. Yeah. However, when we go to back to the main sort of index for this level, which is level 2 selections, what you'll notice down at the bottom, if I scroll all the way down, is fun challenges from Mission Incodable. So if all the programs that we've given you are not sufficient, here are some more. So voting age, height checker, Treasure Island, what they did at your age. And these programs are perhaps a little bit more interesting, a little bit more exciting in many ways than some of the programs that we are presenting students. Because Craig and Dave, we've always had this philosophy on, we teach you what you need to know for exams. We have a very exam focused approach, and we think that's right. Doesn't always make things fun. So we're looking for ways of putting additional programs in that look at the same skills, but perhaps from a different angle, a different perspective. So you've got more material to work with, and more material that might be a little bit more fun than our kind of exam approach, which is equally as important. And these programs, and they're in all the levels, by the way, these programs are not written by us. You'll notice all the way through our website, we're plastering this in partnership with Mission Incodable. Well, what is Mission Incodable? Well, Mission Incodable is actually two young students, two 16-year-olds, Anna and Harry, or Harry and Anna, as you can see on the screen here. And they've literally just finished their GCSEs, and they learned Python for the first time through their GCSEs. And they decided that, we could create some tutorials that are more fun than the stuff that we're doing at school. And that's exactly what they've done. And they created this thing called Mission Incodable. And it's really, really good. If I go over to their website for a moment, this is what it looks like. The coolest way to learn to code. So there you go. We won't look at this in detail now, but you'll notice on their website, it says in partnership with Craig and Dave. So this is very much a two-way thing. We reached out to Harry and Anna and we said, what you're doing is great. You know, coding by students for students, two young people. This is really innovative. We want a piece of the action. But we know all the issues that a teacher will have in their classroom. So can we combine all the issues you think students have with all the issues that we think teachers have into one scheme? That ultimately proved a little bit too difficult, because if you have a focus on exams, you can sacrifice the fun. And if you have a focus on fun, sometimes you sacrifice what's needed for exams. So we ultimately decided, no, let's have two schemes. We'll have Time to Code, which is our scheme, and Mission Incodable, which is their scheme. But what was really important to us is that all the levels completely align. So if you go to, for example, level 2 in Mission Incodable, it's exactly the same skills as level 2 in Time to Code. And if you go to level, well, any level, to be perfectly honest with you, go to any level in here, and it's exactly the same skills. So you'll see those 9 levels exactly match the 9 levels.
And it should be worth saying, this is an ongoing partnership, because Dave mentioned a C# version and maybe introducing extra levels later on, you know, GUI elements to Kinto. We've been looking at sort of OO concepts. We have a very firm agreement with Harry and Anna, and they're on board with us. We're separate entities, but as we expand out Time to Code, we're going to expand that. They're going to expand out Mission Codable in the same way, and that allows us to do exactly what Dave was showing you. You could be using our scheme work primarily, and the kids are like, well, I've got it, but I need a bit more practice. I want to do some activities that are more fun. You will jump off and it will take you to their activities. Yeah, and it's just that breadth of material, and it allowed us to sacrifice, as you were just explaining very well, Dave, none of the things that were important. Yes, we want to focus on exam success, so we're creating a whole bunch of programs for you to learn and try and practice with, which are typical of the sort of programs you will see in an exam. We don't apologize for that. Okay, but I still need some help learning the concepts. I'd like something a bit more fun. Okay, you might not see it in the exam, but here's exactly the same skills, exactly the same knowledge over a Mission Incodable. So it took us a while to get there, but I really feel we've ended up with the best of both worlds with this collaboration. As I said, they're very much on board. They've started their A-levels, yeah, they're very keen to progress this partnership.
Yeah, absolutely right. And this is chock full of pedagogy as well. So we've talked to Harry and Anna about, you know, good practice, and they've identified things that really help them learn through GCSE, and included those things as well. And here's an example of it. So in Mission Incodable, you actually start with what they call a capstone project, which is the kind of the end project, what you're aiming for. And you can run the code and you can see by the end of this, this is what you will be programming. And so they see the end point before they start, which is just good teaching. And so there we go. So here's a little program. Enter the age to the nearest year. Well, if I go with 16, There we are. And it tells you a little fun fact. So we're not doing that in our scheme, but it's a fun little program that you can get from Mission Encodable. So there we go. We're not going to look at this in any detail now. I think what we'll do instead is in future videos, Craig, we'll invite Anna and Harry to come and talk about Mission Encodable, go through each of the levels one by one from the Mission Encodable perspective. And I think when we've done that, maybe we'll cycle back to Time to Code and have a look at all our levels from 1 to 9 so that people can see the synergy between the two schemes of learning. So I think that sounds like a good idea. And I hope that this is a useful introduction to what is Time to Code and why does it exist?
Absolutely. No, that sounds excellent. Yes. So say we're going to be getting Harry and Anna on. Oh, and it's also worth mentioning Mission Encodable is also completely free. There's no sign up or accounts required there. As I say, we've committed with them to develop both sides of our products, in line moving forward. So yes, so come back soon, and we're going to have Harry and Anna on, and we can actually start talking to you about Mission Encodable. So anything else then, Dave? Any other top bits, or are we done with our high level intro? I mean, we are going to do some more videos on Time to Code, aren't we?
Well, yeah, we're going to do a lot more videos on Time to Code. This is just an introduction, but yeah, no, that's it, because we said these videos would be about 20 minutes. It's now 31 minutes. So I think it's time to zip and end. Brilliant.
All right. Well, we'll see you all again soon, when hopefully we can introduce you to Harry and Anna for Mission Encodable. But for now, take care, everyone. Bye-bye.